Good day everyone. Today we're going to do a question from May 2012. Question 6, Part C. This is a waves question and we're going to go through it, examine its components and get to the answer. So let's dive into the question itself. A popular radio station broadcasts with a frequency of 100 by 10 to the power of 6 Hz. Calculate in centimeters the wavelength of the sound waves generated. An additional piece of information is also given. The speed of radio waves is equal to 3.0 by 10 to the power of 8 meters per second. Alright, so there's actually one formula that relates the speed of the wave, the frequency of the wave, and the wavelength of the wave. This formula is V is equal to F lambda. V represents the speed of the wave. F represents the frequency of the wave. And lastly, lambda. Lambda represents the wavelength of the wave. So in order to calculate the speed of the wave, we multiply the frequency of the wave by the wavelength of the wave. So let's dive into this question. Now, what we are looking for in this question, we are looking to calculate the wavelength of the sound wave generated. The information given are the speed of the radio waves and the frequency of the wave. So we have the speed as well as the frequency. So what we need to calculate is lambda, which represents the wavelength of the wave. So we need to calculate lambda. In order to do this, we must actually manipulate this formula, right? So what we do to get lambda alone, we have to get rid of this frequency that's multiplied by it. So to get rid of the frequency, we must carry it to the other side of the equal sign. So since we are multiplying the frequency by the wavelength on the right hand side of the equal sign, if we carry to the left hand side, this frequency now becomes a division. So now we are taking the speed of the wave v and dividing by the frequency of the wave. So once more, in order to calculate the wavelength of the wave, we have to manipulate the formula. So what we must do, we must get rid of the frequency to get the wavelength alone, right, lambda. So we carry it to the opposite side of the equal sign. Since we are multiplying the frequency by the wavelength, by carrying to the other side of the equal sign, we are now dividing the speed of the wave v by the frequency. So that's how we get the wavelength lambda is equal to the speed of the wave v all divided by the frequency of the wave f. So at this point now, we just need to substitute our values. So the speed of the wave, right, the speed of radio waves, 3.0 by multiplied by 10 to the power of 8 meters per second. I'm now dividing this by the frequency. The frequency given here is 100 multiplied by 10 to the power of 6 Hertz. I can easily compute this in a calculator and I would end up with 3 meters. Remember that wavelength is measured in meters. So the wavelength is 3 meters. However, we have to actually calculate an additional piece. We want to calculate in centimeters. Recall 100 centimeters is equal to 1 meter. Therefore, the wavelength lambda is equal, we have 3 meters, so it's 3, and because 100 cm is equal to 1 meter, we multiply by 100 centimeters here. And we end up with 300 centimeters. Thus, the wavelength of the wave in centimeters is it's actually 300 centimeters. And this is how I go about calculating the wavelength for this question, right? It's very simple, and I really hope this video was able to help you. So if you have any more comments, questions, or concerns, feel free to leave them below. Thank you very much. Have a safe and enjoyable day.